This lesson is going to draw from Chapter 10 of the Technical Mathematics textbook and is going to be an introduction to radian measure. So far in your classes you've probably learned about degree measure and possibly about radian, but we're going to review it. So when you talk about degrees, we know that within a circle there are 360 degrees, and this is a rather arbitrary definition of how to split up the circle based on some historical context. The radian, however, is based on the circle itself. And if you look at the circle, if you look at the center, you know that the distance between the center and the edge of the circle is the radius. And if you were to take that distance, r, and place it instead on the circumference of the circle, the angle that you would get is what is referred to as 1 radian. So if we write down that definition, a radian is a unit of angle measure such that when the length of the radius is measured on the circumference of the circle, the angle inscribed is 1 radian. So this is our definition. That's where it comes from. Now we need to know how many radians there are in a circle. Well, technically, the number pi is defined as the ratio between the circumference and the diameter of a circle. And we know that the diameter is really twice the radius, because the diameter would be this whole distance here. And so the radius is half of that. So pi is really c, or the circumference, over twice the radius. Now if we multiply that over, we get that the circumference is equal to 2 pi times r. And this is probably a formula you've seen before to determine the circumference of a circle based on its radius. So it takes 2 pi radians to go around a circle. And it also takes 360 degrees to go around the circle. So we know then that 2 pi is equal to 360 degrees, and if you divide both of those by the 2, you know that pi is equal to 180 degrees. And then we can use this relationship to go back and forth and to convert between these units of measure. So let's do a few examples. If you want to change, for instance, the angle 30 degrees over 2 radians, you want to get rid of degrees, so you're going to divide by 180 degrees and multiply by the pi, because since those two things are equal, we're just multiplying by 1. Then our degrees would cancel, and we would be left with 30 pi divided by 180. And we would want to reduce that fraction. We don't want to leave it like that. And we know that 30 divided by 180 is 1/6, so we end up with pi over 6. We can do another example, 45 degrees. Again, we're going to multiply by pi over 180 degrees. And then, again, you end up with 45 pi over 180. And if you reduce this fraction, you end up with pi over 4. Now I want you to pause the video for a second and do these next two examples of 270 degrees and 72 degrees. Okay, so if you worked out those two examples, you should have gotten that 270 degrees is really 3 pi over 2, and that 72 degrees is 2 pi over 5. Again, if you need to pause the video at this time to go back and verify or fix anything, please do so. Okay, at this point we're going to go over and we're going to change the other way. We're going to say, okay, if we start off with radians, how do we convert over to degrees? because some people are just more comfortable with degrees. So if we start off with pi over 3 radians, then, and usually we don't actually use the notation radians or any type of unit. It's understood to be there if it's got a pi or if it's just an angle without a measure, which is why it's really important that you put the degree symbol anytime it is a degree, because if it's not there, it's understood to be radians. So what we want to do here is we want to get rid of pi, so we're going to divide by pi, and then we're going to multiply by 180 because we want to get the degrees. So those pi's cancel out, and you're left with 180 degrees divided by 3, and that is just 60 degrees. Do another example. We've got 7 pi over 4. Again, we want to get rid of pi, so it's going to go in the denominator. We're going to multiply by 180 degrees because those are the units that we want to get to. And then we're going to get those pi's to cancel out. It's also probably easier at this point to simplify the 180 divided by 4 instead of multiplying by 7 first. So we know that 180 divided by 4 is 45 degrees. So we end up with 7 times 45 degrees, which is 315 degrees. Now again, I'm going to ask you to pause the video at this point and to do the next 2 examples. Okay, so for those last 2 examples, you should have gotten that 3 pi is really 540 degrees. And if you think about this, this really means that you've gone around the circle all the way once, and then another half of a time, because you've gone 3 pi. 2 pi would have been 1 full rotation, and then another pi would have been half of the circle. So you've gone 3 times, or 1.5 times around, which is 540 degrees. For the other one, again, these don't have to be fractions. You can have decimals, so 2.4 times 180 ends up being 432 degrees. Now the last thing I want to do in this intro video is to talk about reference angles. Reference angles are going to be helpful a little bit later on in this section, so I want to talk about them here. Essentially what a reference angle is, and we use the letter alpha to represent the reference angle. The reference angle is the measure from the nearest x-axis. So the first thing we want to do is we want to draw our angle and then find where the x-axis is nearest, and then that is going to be our reference angle, and the reference angle is always positive. So if we think about 2 pi over 3, and one of the nice things about radians is that you don't have to memorize anything other than the fact that this is pi and this is 0. So if you want to divide this line here up into 2/3, you would say, okay, well this is about 1/3, that's about 2/3. So if we want to go around to 2/3 of pi, we end up with 2 pi over 3. And again, we're just kind of splitting up the line into thirds. Now, if we want to find the reference angle, the nearest x-axis is actually the negative x-axis. And so we're going to draw the angle up here. We want to find the difference between pi and 2 pi over 3. So we want to take pi minus 2 pi over 3, which is really 1 minus 2/3. So we end up with 1/3 of pi, or pi over 3. Again, we would need to find common denominator. Okay, we'll do another example here. If you look at this one, you've got 9 pi over 4. And again, like I said, we know that this is pi over here, this is 0. If you want to mark these off, this is pi over 2 and 3 pi over 2. So we've divided this up into quarters of 2 pi. And now if we want to look at 9 pi over 4, okay, well we know we've got to divide this circle up into quarters. So we've got 1, 2, 3, 4 if we get here, and then 5, 6, 7, 8 quarters would get us back around, which makes sense. Pi is equal to 8 quarters pi. And then we would want to go one more. So essentially we've gone all the way around the circle and then back another quarter to get to our angle, which is 9 pi over 4. Now, our reference angle here, again, the nearest x-axis is what we're looking for. In this case, it's the positive x-axis. And so all we want to do is find the difference between that starting point and our ending point that are the nearest there. In this case it's 0, and if you look here it would be pi over 4 because we've gone a full, if you want to write 0 can also be thought of as 2 pi. In this case you would take 9 pi over 4 minus 2 pi, which is also 8 pi over 4, and you would end up with just pi over 4. You've gone a quarter of the way. It might be easier to kind of see in the picture there. Okay, we've got one more example here. And again, if you need to pause the video at any time to write things down or to figure things out, please feel free to. This last one has a negative here, so we've got to be careful. We're actually going in the opposite direction. We're going clockwise now. So in this case, we need to divide it up into fifths, which might be a little bit harder to see, but essentially you want to be able to divide each line up into fifths. And so you're going to kind of ignore the dark black lines that run on the y-axis. You just want the blue lines that I've drawn in there, because now you've got 1, 2, 3, 4, 5 fifths. And you want to go negative, so we're going to go this way. We're going to be going in the negative direction or clockwise. So we want to go 1, 2, 3, 4, 5 would get us back to the line because that's 5 fifths. And then 6, 7, 8. Again, like I said, you want to make sure you kind of ignore these black y-axis here because that is not one of the lines that we're counting. Okay, so we've gone 1, 2, 3, 4, 5 is right here, 6, 7, 8. And this is negative 8 pi over 5. Now again, if we want to find the reference angle, we need to find the nearest x-axis, which in this case is the positive x-axis. And if you look here, you've gone 1, 2. So in this case, alpha is 2 pi over 5. All of these are alpha. And these are our reference angles. Like I said, these are going to come in handy with the lessons later on in this section.